Hello, I'm Stephen Hardy, Editorial Director of Lightwave. The Consortium for Onboard Optics, or COBO, has been active for several years, creating consensus and standards that will help data center networks keep pace with present and future demands. To fulfill this task, COBO needs to keep its finger on the pulse of data center network trends. And to talk about some of these trends, I'm speaking with Brad Booth, President of COBO. Brad, what are some of the trends that are occurring in data centers that people should be aware of?
Hey, Steve. Yeah. So one of the things that we're starting to see, as we go up in faster and faster data rates these days is a growing presence of optical connectivity inside our data centers, where we have in the past been able to use copper cables for reaches from the server to the top of rack switch. The trend is moving away from that towards the future. I mean, there's people that are still saying, hey, we could do this with 200 gig SerDes, but when you start asking the questions about how they're going to do it, 1 meter passive reach doesn't really get you from a server to the top of the rack. So we're seeing people looking at optics more seriously, in the sense of, hey, I may actually have to consider deploying optical interconnect inside my rack. And if I do, or even if I want to say I'm going to take the top of rack switch out of play and I'm going to go to my middle of row switch, if I'm going to do that, I need to understand what the implications are for using optics. And we've seen in our industry for a long period of time the consensus that optics are expensive, that they're difficult to work with. That's got to change. And I think this is where we've started looking at, how do we work with optics going forward? How do we drive some of the capabilities to make optics easier to use? Integrating the optics with the electronics, investigating how you can do optical traces on printed circuit boards instead of having to use the copper traces. These are all things that our industry has to start investigating broadly, because it's the only way we're really going to be able to get some of the escape bandwidth out of these next generation chips. And we're seeing that happen. I mean, if you look at what's going on with CPUs and GPUs and even networking silicon, there's a lot of companies investing and working with trying to bring optics integration into these parts, whether it be a near package optics or a co-package optics, or in some case even playing with different types of optical material. And this is all good for our industry, because obviously this is going to drive a greater level of innovation for data centers to be able to build upon. So, in summary, I think the key that people have to be aware of is pay attention to optics. Make sure you're expressing your concerns, your needs to those that are building these systems, because otherwise, it's just an interpretation of what the end customers are going to need.
So speaking of optics and innovation, there's a lot of talk now about moving to 800G and even 1.6T Ethernet. What do you see as the impact of these new transmission rates?
So these are obviously satisfying a need that's coming from a lot of the hyperscale users. Part of that is driven by just general volume of end users, doing things like streaming and various other things. It's also being driven by the big push in AI, machine learning type algorithms. So what we're seeing is a need to drive higher and higher bandwidth. But in doing that, we're starting to bump up against, what people have typically called in the past Shannon's limit, where we're starting to push the technology to the point where we're paying more for power than we're getting, equivalent bandwidth out of it. So you're starting to spend a lot in power and in cost to be able to achieve the same reach on some of these interconnect technologies. And that's of concern, because a lot of the data centers, there's a big focus on how much power these data centers use, and how can we become more energy efficient and maintain some of our sustainability requirements. So one of the big focuses on that, one of the big concerns as we continue to push bandwidth, is how do we fit within the previous power envelopes that we've had. And this is where people are looking to innovate with new technologies, new topologies, new ways of building, new ways of thinking about how do I put a whole system together. We've seen with pluggable optics, there's a significant amount of power that sits there on that faceplate, and the thermal requirements for those, is pretty high. We're seeing some of these next generation 1.6T optical modules, quoting into the 30 and 40 watts. When you think about it, right, that's an order of magnitude more than what we've done with 100 gig. And so this is a massive amount of power increase that we've seen, and we have to focus on that and figure out how we pull that power out. And some of the ways that we're looking at that is, co-packaged optics with a tighter integration. The other way is do we need all that circuitry in there? Is there stuff in there that we can optimize on? Can we do a better partitioning of our networks to actually reduce the power in some of them? And that work is continuing, and it's good for people to be paying attention to that, because it will shift some of those requirements, where someone may have said before, hey, I need something that's capable of doing 2 kilometers. They suddenly may say, you know what, my topology's changed. I only need 500 meters or 100 meters.
So you were mentioning that there are continuing questions these days about how long copper is going to hang on in the current environment. What's your feeling about whether copper interconnect will continue past 224G?
Boy, no one really likes to bet against copper. I've worked on copper technologies in the past. And one of the things that I saw is eventually you get to a point where you bump up to a limit. We saw that with 10G base T, great technology, lots of capability, trying to do 100 meters over copper cable, unshielded copper cabling. And eventually what was the big damaging factor of it was just the power required to achieve that reach, that 100-meter reach, was a death knell to it. It just, we created a very sensitive device that, unfortunately, someone's hand radio could take down. And there was a lot of learnings from that, hey, sometimes innovating and pushing the technology is great, but at some point in times, you have to stand back for a minute and go, am I really doing the right thing, by pushing this to its maximum physical limits, or should I step sideways and find a better approach to that? And I think there's been a pretty big focus in the industry to say, what do we do if we have to make that sidestep? Because we're used to using optics today. All our optical modules have an electrical interconnect on the backside of it. To be able to remove a lot of that requires some level of integration. But it also requires some analysis. I mean, are we still doing the right thing by saying we're going to go 224G? Do we instead consider going slower and wider, sort of like what has happened with PCI Express buses and stuff like that? They typically try to keep their, baud rate very low, but go very wide. And so I think there's a lot of people starting to approach this, think outside the box of how do we solve this going forward, because really beyond 224 gig electrical signaling, it gets pretty difficult. I mean, I know there's people that are saying, hey, we can get to 400 gig electrical signaling or 800 gig electrical signaling, but most of those people that are telling you that are telling you, hey, this is not leaving the substrate. It's not leaving the multi-chip module. It's probably not even getting down to a PCB material, just because the losses are too high for that to be even, possible to operate well.
Thank you, Brad. So as you've heard, the data center space faces several challenges, both now and over the next few years. Fortunately, there are organizations such as Kobo who can help the community meet those challenges. For Lightwave, I'm Stephen Hardy.